Okay, so this is second semester, 7th grade math, unit 4, lesson 4. Okay, so today we're going to be determining proportional relationships from graphs. So here's the definition I need you guys to write down. You can use a graph to determine if a relationship is proportional. If a relationship is proportional, its graph is a straight line that passes through the origin. The coordinates of the origin is 0, 0. So here we have a table of values, and I ask that you graph them. Now right away you should kind of recognize that for the outputs, there's something going on here. Do you guys remember the terminology we'd use? Do you guys recognize something going on, a pattern? Yes, Trinity. It's increasing. For every input you have an increasing output, yes? So that is an increasing, a positive function, yes? You could say it's geometric. Why would you say it's geometric? You're multiplying by a constant. What's the constant? Nope. You're close though, but I like that you use vocabulary, so that's correct. It's a geometric pattern for my outputs. And it's also another pattern too. Nathan? Right, so you are adding 250, but if we're adding 250, it's also what kind of pattern? Do you guys remember what this is? It's an arithmetic sequence for my outputs, okay? We have a common difference of 250, but it is also a geometric sequence because the outputs are multiples of what number? 250. Remember when we wrote our rule, if it was both geometric and arithmetic, we didn't have to make an adjustment. Do you guys remember that? Right? But sometimes we had to make adjustments if we were trying to write our rule. So now you're going to see we have a name for this with linear functions, and we're going to go over that today. So over here, just to tie this in with what we learned yesterday, plus 1. Okay, so we're going to graph this, and this is what your graph should look like. Now something I want you to recognize, my graph, if you notice, it goes to the origin, right? Do you guys remember from yesterday that, do we have to pick, does it matter what points I pick to calculate the slope? No. Remember yesterday we had the line and I said, hey, use A and D and calculate the slope, right? And then you guys used 2 other points, C and B, calculate the slope. Were the slopes different? No, they are all on the same line. They were collinear. So it didn't matter what 2 line points you picked, you would still get the same slope. So for this one, let's pick out 2 points and we'll calculate them. I'm going to start over here. So my run is how much? Plus 1. And my rise is how much? Look, this is 500. This is about halfway up, right? So this is plus 250. Okay? Do you guys remember that the formula for slope, remember m is the variable that we tie to slope? Okay, sometimes you'll see m, sometimes they'll spell out it as slope. Slope equals the ratio of rise over the run. Okay, and if we calculate our slope here, what we end up with is 250 over 1. Okay, are we good? Any questions so far? Now I want to come up with my formula, my rule, my function. So my function, do you guys remember how to write the function given the slope? What is it going to be? Kalila. It's going to be the slope in front of what? In front of the x, right? So my slope is going to be is going to be the coefficient in front of my x, or when I'm multiplying to my variable x. Now, this function, since it goes through the origin, I don't have to make any adjustments, remember? Okay, I could put plus 0 and it doesn't change a thing. It goes through 0. If I plug in x as 0, y will be 0. Okay, so that's my function. So just a little bit of recap. If you have a linear function that goes through the origin, it is a proportional relationship. And we're going to see why here in a moment. Can somebody tell me, do you guys remember our unit on proportions, ratios and proportions? There's how many ways to write a ratio and a proportion? There's 3. Can you tell me the first way? Can one person tell me the first way? Yes. Right, we can write it this way, 250 colon to 1. What's another way we can write it? Yep. As a fraction, we already have it in fraction form, so 250, 1, that's the other way. What's the third way? Who's got the last way? Unisa? 2. The word 2, so you go 250 to 1. Are we good? Okay, so moving along. Here's what we're working on. You can use tables and graphs to decide whether or not 2 quantities have a proportional relationship. So this is actually one of the homework problems. So I'm gonna work out the first 5 homework problems with you. There's a total of 16. Before you leave out of here, you should have more than half of your homework done. So the tables below show a person's earnings at the end of each year at 2 different banks on a deposit of $100 over a 5-year period. So somebody deposited $100 into 2 different banks, Bank A and Bank B, and for 5 years, this is the data, or this is how much interest they accumulated each year. This is how much interest they got each year, how much they earned. Okay, for each bank, earnings include simple interest paid annually at the same rate each year. In addition, Bank B gives depositors a $5 bonus when an account is first opened. Okay, so there's a difference there. Now, what I want you guys to do is take a look at Bank A, Bank B, draw your T-chart, and then I want you to graph these 2 functions on the same grid, on the same coordinate plane. Do you guys understand what I mean? I don't want 2 different separate graphs. I want them both on the same coordinate plane. Because what we need to do is we need to analyze how they're similar and how they're different. So we want them on the same graph. draw a line through it. I'm about to go over it with you guys. Okay, so let's take a look at these two graphs. Hopefully you guys have enough time to go through this. So these are the questions that are in the homework today, but first we got to create these graphs for bank A and bank B. So for bank A, I'm going to graph those points in red. For bank B, I'm going to graph those points in blue. Got it? Bank A, the first point is in 1 year you earn $2. So here we got my graph. In 1 year, I earned $2. Okay. And then how many did I earn in 2 years? $4. Yep. And then how many did I earn in 3 years? $6. And then in 4 years? $8. And in 5 years? $10. Okay. That was bank A. Now what about bank B? Now over here, if you notice, in 0 years, how many did I earn in 0 years? $0. They didn't give you anything when you opened your account, right? But for bank B, when you made the deposit, you got how much? $5 at the bat. Okay? And after 1 year, how much did you earn? $7. 2 years, how much did you earn? $5. What? $9. Okay. And in 3 years, how many did you earn? 11. 4 years? Very good. And then in 5 years? $15. So now what you need to do is let's connect our points. And do you notice something about our graphs? What do you notice about our graphs? Say again? You did earn a little bit more. Okay, what else? At Bank B, yes. What else? Joshua? I like that you're getting close. They have the same pattern. Okay, you're getting there. Their functions will be similar, yes. They're not both proportional relationships, nope. If you were to see these lines not on the coordinate plane, what would you say about the lines? They're parallel lines, right? And what do we know about parallel lines? They never intersect. So I'm just going to put some notes over here to the left. They're parallel lines. Okay. What about their slopes? You say they have the same slope? That's something big. Let's calculate the slopes. Remember from yesterday, does it matter what 2 points I pick to calculate the slope? No, it doesn't matter. Any 2 points will give us the same slope. So let's go ahead and calculate slope. I'm going to calculate the slope for bank A. And let me go ahead and label this. This is bank A. And over here, this is bank B. All right, so let's go ahead and pick. I'm going to just pick 2 points out, and we're going to calculate the slope. So I'm going to pick this point right here. What's the run from this point to this point? The run. The run is 1, plus 1, right? Because I'm going to the right. What about the rise? The rise is what? My rise is going to be plus 2. So my slope, m, is the variable we use for slope. M slope equals the rise over the run. And in this case, that equals 2, positive 2, over 1, right? What's the function or the equation for this line that represents bank A? Does anybody know it? Let's keep our slope in fraction form. But you're right. If it's a whole number, you would turn it into a whole number. Okay? So what's it going to be? My function equals what? 2 over 1, because we like to 2 over 1 times x. And does that work for all my values? If I put in 0, does it give me back 0? Yeah. If I put in 1, does it spit out 2? Yeah. Right? What about 2? If I put in 2, does it spit out 4? Yeah. Mm-hmm. Okay, so my function's good. Now, I can't call bank B function f. I got to rename it. So what's after f? G. So the function that goes with B, I'm going to call it G, but we're still using x. Now, first we need to know the slope of this line. What's the slope of this line? M equals, what is it? Let's pick out 2 points. What's my run? 1. What's my rise? My rise is plus 2. So we have the same slope, positive 2 over positive 1. What would my equation be, or my function be, for bank B? 2 over 1 times x. And then does 2 over 1, does that work as is? No, we have to make an adjustment, right? What would the adjustment be? If I plug in, let's plug in x equals 1, and do you see where it's at on the graph? At x equal 1, we're at 7, right? So if I put 1 in here, what do I get? If I put 1, I get 2, right? But I don't want 2. I want what? 7. So how do I fix this so I get to 7? I put plus 5. And remember, this plus 5, that number over there has something to do with the line, a property of the line. What was the property of the line? It's the y-intercept. Do you see where my bank B graph crosses the y-axis? The y-intercept. That is this, and that is that point. 0, 5. Okay, so we have 2 different functions. They are parallel. They have the same slope. That means they're parallel. This one goes through the origin, so I could have said my y-intercept is 0, right? And that doesn't really change my function. Okay, so those are my 2 functions. This is just a brief kind of introduction to what we're working on today. Now, from the definition we wrote up earlier, which one of these fits the definition? I had you guys write something out at the beginning of class. What is it, Jayla? Bank A, what about bank A? What's the definition say? Okay, so bank A, the function for bank A is a proportional relation because that graph passes through the origin. Now, we're not done yet because watch this. Here's why it's proportional. And we talked about this earlier. We know what a proportion is, right? It can be written as a fraction, with 2, with colons. But watch what happens up here. So I'm going to take this value, these set of values, and I'm going to write it 10/5. What's 10/5 simplify to? 2, right? I'm going to pick any of these values because you said that bank A is proportional, right? So I'm going to pick any of these values. What about this? So 6/3. Does that also simplify to 2? Yeah. Okay. Let's go ahead and do 1 and 2. Is 2 over 1, does that simplify to 2? Yeah. Yes, so actually what we're noticing is all of the ratio of inputs and outputs, they can be simplified to the same ratio. the same fraction. Do you understand? But if you notice, even though bank B is a parallel function, it's a graph of a line that's parallel to bank A's graph, can we say the same? 15 over 5, what's that equal? 3. Well, what about 11 thirds? Does that equal 3? No. Nope, these are not equal. As a matter of fact, none of these are equal. So do you guys understand the difference between a proportional relationship and a non-proportional relationship? Are we good? So now here's what you guys need to do, because we're done with our lesson for the day. I did about a third of your homework with you just now. I need you to complete this homework assignment